Yeah.
IEEE's
So what do we start?
IEEE floating point IEEE in computer architecture.
Okay, we will discuss floating point later. Okay.
Okay.
Yesterday
Mm-hmm.
one question was left, so just want to finish that question, and after that we'll discuss another topic maybe. Or before that,
Mm-hmm.
just okay. So what we do? STA we will do. Okay. STA
STM.
do and FIFO, and also yesterday I started some concept of uh, two flop synchronizer. So there also I studied a little bit more extra. So I will also explain. Like yesterday, you asked one question that okay, so my data will goes, but somehow there are some uh, metastable condition is happened, so that you use two flop synchronizer, but at the end you find there's zero. So obviously that's make no sense that you give some pulse, but your output is zero. So entirely you say that your data is removed or you erase your data, right? So that kind of situation how to tackle, and this kind of is like yesterday maybe I said you that ultimate goal is to remove metastable, that's okay, but at the same time whatever you data send, that also be should not be corrupted or should not be encrypted. So previously I was wrong that most recommended just remove the metastable, and irrespective of data don't think too much, but you should also think about data. Like ultimately the data will provide to your circuit, so that your circuit is working properly, right?
Mm-hmm. So
Okay.
like
Gaurav will, I
how
think
will you
Gaurav will come.
like
Okay,
कौन
just
who will
Gaurav,
come?
Gaurav admit.
Who's who is Gaurav?
Yeah.
अच्छा, hello Gaurav.
So just one question left, I think. So we'll go on that question. Okay.
Gaurav from was from which college? Like bits.
Yeah,
अच्छा
it is.
93 yes. CSPL ना? हाँ हाँ वही communication and signal processing. Okay okay
Okay.
okay. Like what did you concluded from that question? You were concluding something, Pallav.
I said that not concluding that the CDC problem, like synchronizer flip flop, I will say like extra more. Like I studied around 10 page extra. So whatever they are saying, so I will explain that. But
Mm-hmm.
and after that we'll start
Mm-hmm.
STA problem.
Okay. We'll also go for that PDF uh, of this that metastability PDF.
Yeah, sure. So here the 10th number problem, that specification can be given in a different way. Understanding the specification is important here. Given the following FIFO rules, how deep does the FIFO need to be to prevent underflow or overflow? Okay, frequency clock A, frequency clock B by 4, period enable B equal to period clock A multiply 100%. Okay, and duty cycle of enable B is 25%. Okay,
Like frequency is like if frequency of B is 100, then frequency of A is 25. Like that.
okay,
Period
okay,
is if the period is around 10 nanosecond, then period of B will be around 1000 nanosecond.
If suppose my clock is 100
Okay.
and clock period of enable B, that is my period of clock A. Period of clock A into 100, that is 100 hertz. So 1 second. Okay, can you see my see the screen?
Yes.
Yeah. So this is my frequency. Like this is the equation. They said that frequency of
Uh,
clock A equal to frequency of clock B by 4.
uh,
And if suppose I assume that frequency of clock A is 100 hertz and frequency of clock
um,
B equal to 400 hertz. So obviously like
um,
frequency of clock B equal to 400 hertz. And enable period is like what they said enable B equal to frequency like time period of frequency like clock A into 100. So that is 1 second. And duty cycle, they said that enable B duty cycle is 25%. So here this 25% that clock is high, sorry, enable is high, and rest of the 75% uh, my clock enable is down. Okay, got it?
mhm.
Yeah.
Good evening.
Yeah. Good evening,
Good evening,
Synergist.
bro.
Actually, Synergist, we already done the problems, like almost done, but 10th number problem is just left yesterday.
Okay.
Okay. So,
Any other question? Like apart from the PDF have been discussed here.
yeah, we already
Yes,
discussed
puzzles,
yesterday,
puzzles.
and puzzles will, like
Huh?
yesterday, we discussed one puzzle.
Okay. Okay.
And
Okay.
clock domain crossing we discussed. And
Okay,
metastability.
that I already like I told again. I tell again, like I discussed the that concept again today. Like
Mm-hmm.
STA and metastability, like synchronizer, two
Okay.
syn
Okay. Okay.
two synchronizer flop.
Okay.
Okay. So in this question, they are like specification can be given in a different way. So it's like totally understanding the specification is important here. So what they said that given the following FIFO rules, how deep does the FIFO need to be prevent underflow or overflow? So underflow and overflow, how deep does? Okay. So this is the data and this is the right. That my F clock equal to F clock of B by 4, that's the given, and F clock of A is, if suppose I assumed 100 hertz. So obviously my F clock of B equal to 400 hertz, and enable of B, that they already said that time period of F clock. So obviously if 100 hertz frequency, so 1 by 100 and that multiply into 100, because this is the relation period clock A into 100. So that is the period of enable B,
Ah,
and the duty cycle
okay,
of
okay.
enable B is 25%. So obviously this is 25%, as you can see, that my 25% of the time it's high and rest of the 75% it's low. Now they said the overflow and underflow condition, something like they written overflow and underflow. So overflow and underflow is what the like, as per my understanding, overflow is something that when your FIFO depth is totally full and you want to write again, so that time overflow is occur. Like you want to
Mm.
write operation again in the FIFO. Suppose this is your
Yes,
FIFO,
yes.
and totally suppose this is some data will be here also present, here also present, here also present, and here also, like almost full. Then again, your enable signal is high and tell that uh, write the data again. So this is the condition of overflow. And suppose your FIFO is empty and you want to uh, want to operate like operation, you want to perform read operation. So that time it's like underflow, I think. Right or wrong am I? I think that the condition maybe. Assume some numerical values of the like 100 megahertz is here, they assume, and if the clock is 100 megahertz, okay, if the clock A equal to 25 megahertz, obviously, so yeah, in specification given, the burst length is specifically indirectly, the burst length is 100.
How much length is anchored?
I don't know. Yes, there are no mentioned. The burst length is 100. In the
I
specification
think
given, the burst length is
I think
specified indirectly.
period is multiplied by 100 now.
Yeah,
To
yeah, yeah,
get
yeah. So that's the, I think the uh,
because when we calculate the burst length,
yeah, that's the, I also I assume that that kind of things they are, or they want to say it. If we multiply by 100 into a clock enable, so obviously if your enable B period is high, so obviously at that time you want to write some data.
uh,
So indirectly they said 100 is multiplied with the period of clock A. So obviously the that 100 like you in period of enable B, that is your, I think, the burst length. Synergist, do you want to add something
I am still thinking that how they take 100.
in
I
the
think your concept
specification?
is right that it
Yeah,
is clock A into 100. That's why we take 100 here.
yeah. So the record time for one data is that is 14 for according to the clock, and the time required to write one so 400. Acha, okay. So we'll take the like in hertz. Okay, they took like in megahertz. We will take in hertz. Okay, so we'll not go through that numerical, but we will do our numerical. So what's the total time period we get? Enable B, that 1 nanosecond. Sorry, 1 second. That the total period. So your FA clock is 100 hertz. FB clock is 400 hertz, and you want to send data from your module A, like this is your A module and this is your B module, module B. You want to send data from here, and you want to send data from Uh, Sorry. Uh, they said that your data should be sent from clock A to clock B.
B2 है B2 है I think
Huh?
data is going from B है and B2 है I think
B2, but here uh, specific can given in the different way. Anywhere given the
no FIFO we use like when high frequency module giving the data to low frequency.
yeah, but here like in most of the case previously that uh, the data sent from
Uh,
higher frequency to the lower frequency. Like
हाँ हाँ
mo
So here it should be B2A.
here I think yeah, it's
actually, in the last cases, mostly we were sending the data from low frequency to high frequency, and this question
no
is
no
like
no. Here
continuation.
previously we sent the data from high frequency to low frequency because high frequency write speed high, but read speed is
Ah,
low. You
ah,
just
हाँ
said
No, no, no.
opposite.
Check. There are so many questions like if read frequency is higher than write frequency, then there is no use of FIFO depth. Nah.
Actually,
Oh, got
that
it. Yeah.
this question number 10 is the continuation of those cases only. Like,
Here one is enable clock also present, and here also one enable signal is present. Enable signal is said 25% duty cycle,
Ah,
and also it's
ah,
multiplied by 100 of clock 100. So my here clock suppose you generate 100 instructions, like 100 multiply, so 100 instructions, that is 1 second the data that we already got. And here your frequency is 100 hertz. Here is your frequency is 400 hertz, right?
hmm. Yes,
And
yes.
now, so the scenario is this clock is uh, high, 100 hertz. So obviously something like that. And I assume that this duty cycle is 50%. This is my 100 hertz something. And 400 hertz, it would be like 400 hertz. So obviously it's like becomes small. 400 like one fourth something like that. Oh, it's like just a second. So first I draw the B
mm,
clock, something like that. This is my uh what I said. This is A clock B. This is my 400 hertz. If suppose I want to make 100 hertz, then obviously the time period of uh, how many 400. So this is
Increase by four
400.
times.
Oh, it's a little very long, I think. Okay, whatever.
mm,
Sorry,
like 400 should be small now.
something like that. This is my 100 hertz,
Mm,
right?
Yes, yes.
But here's another thing is said that your enable is 25% duty cycle. So obviously 25% duty cycle. and 400 hertz if the clock is, that is enable B, right? Enable B. That is enable B is 25% and enable period is enable.
What is the duty cycle of A?
Oh, sorry. Period of enable B is period
By
of clock. One thing, like, are you noticed? Period of enable B equal to period of clock A into 100.
ah,
So when 1 nanosecond, between the difference is 1 nanosecond. Okay, got it. So ultimately it's working on 1 hertz, I think. Total period of enable is 1 second. And if my 1 second time period, so between this period, something like that, this period is my total 1 nanosecond. 1 second, sorry, because that is my enable time period, and 25% of 1 nanosecond, that is I think how many time? 0.25 second, that will be on. So 0.25 second, and what's the data data sent at the 0.25, like what's the total time? So at 100 clock 100. Okay, got it. Just a second. Clock A. So my clock A was frequency of clock A. Suppose I already take that 100 hertz. So 100 hertz time period is 1 by 100. So that is my 0.1 millisecond. So one data transferred in 0.1 millisecond. So there are 100. So 100 into 0.1, sorry, yeah, 100 into 0.1. Frequency is 100. So one, uh, there are some calculation mistake, I think. 100 hertz. So 1 by 100, 0.01, sorry, nanosecond, 0.01 second, and this multiplied with 0.01. So 1 second. That's the total time required. But my data's read speed is 400 hertz. So 400 hertz. And how much data? I'm confused. Can you help me?
I can go with this specification here given. Like frequency of clock is given, like that way we can cross. Then it will be easier, I think.
Yeah, I also do the same way, but I will take another clock frequencies.
Like if you take
400
clock
hertz.
A equal to, you take clock A equal to 100 hertz, clock B equal to 400 hertz.
Yeah. So just a
Then we
second.
can calculate the time required. Okay.
Yeah, just a second. Mm. So that the calculation I did, that my clock frequency of clock is 100 hertz. So its time period is 1 by 100, and thereafter the 100% will done. So the 100 means burst length is 100. So 100 into 0.01. So the time total it take 1 second, right?
To write all the data in 1 second. But there is one thing that enable B or something like that in the question. Huh?
Enable B is that's for read operation, right? Your B
Okay,
module is
okay, okay.
accept. So B module
Yes,
what
yes, yes,
says
yes,
that duty cycle is 25%. So something like that, your B. So this total time period is 1 second. Okay.
yes. Okay.
and this period
Okay.
is your
Now
0.25 second.
this is the read time.
This is the read time. Like enable signal is on here.
Yes. 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 Yes.
And in this
Can you
0.
skip? Can you go to the question?
Yeah, just a second.
Ah,
In 0.25 seconds, suppose this is your
okay. Okay.
0.25 seconds, your data enable signal is high, but your
Ah,
clock is working at 400 hertz.
Arch
So
means
in
it is the time period of this thing is
400 hertz means like 1 by 400. So something like that,
ah
1000. So 2.5, sorry,
millisecond.
millisecond. Okay.
Okay.
So your total time is
Now
0.25 second, and your time period is
no no
2.5.
no 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 no. I think it will be 2.5 into 1/4. Then it will be the time of the read operation because
No, no,
that
no, no.
time enable B is on.
No, enable period is this na total, and your this period is
This is
something 2.5 millisecond. But your enable total time period is 0.25 second. Okay, I will explain again. Suppose this is your module B, means read block. Okay,
ah, ah,
here data goes, and here is my like clock. Clock frequency is 400 hertz. Okay, here is one enable signal. Enable B.
yes.
That time period is 1 second, means 1 hertz, and 0.25 duty cycle. So if I make, uh, could you get like how it's one hertz?
This is 1 by 100 into the time period of clock A.
Yeah. See here, it said
Sorry,
that
100
period of
into period
enable
of
B,
clock A.
period of clock A into 100. So period of clock A,
Hmm.
what? Period of clock A is 100 hertz, right?
1 second.
Sorry, period of clock A
No,
is
1 by
100.
100.
1 by 100.
1 by 100.
Yeah,
Yes.
1 by 100. And how it's like 100 into multiply by 100. Like if I enable B,
Ah,
that is 1 by 100
yes.
into 100. That
Ah,
is
so
1
one
second.
second. Ah,
So this is your enable period. And enable period said 0.25 duty cycle. So total
ah.
1 second is your one clock of duty cycle. Enable time. Like that. This is your total 1 second. And this is your
Okay, okay. Now I
25% duty
understood.
cycle.
Ah,
This is the
means
enable.
these are 20. Okay, okay, okay.
Everyone got it right?
Hmm.
So here's
Yes.
the trick.
What the trick?
This is time period is 0.25 and
Uh,
second, but here the clock is fluctuate at 0.25 millisecond.
Hmm.
Okay, so it's a look like that. Suppose if your enable signal is high, so this is your enable signal is high, like entire the time period also like dot dot dot. It is high, but your clock is look like that. Got it? This is your clock B,
Hmm.
that is 400 hertz. So this is the I think trick. There. and this is your total, like this distance something like again goes, this is 1 second, so it's 1 hertz. Enable signal is present for 0.25 second. So total how many operation will we can do? So if this is my total time period, that is 0.25 millisecond, right?
Second.
Yeah.
Yes.
So we'll read, and also read operation
In
also
one
be
second.
performed. Read operation also be performed, like write operation. Sorry, write perform at 100 hertz.
Uh,
1, 2, 1, 2. Something like that. This is my 100 hertz. This is write. This is read. This
uh,
is read enable. Got it?
yes.
Yeah. So now the thing is, so one write operation is here entire period. So my frequency is high. So at that time period only one read operation will be done. Why one read operation
Hmm.
will be done? Could you understand? Or should I explain?
Why one read? No. I think two or three read operation will be done now.
No. Why? I tell you. Suppose analogy is like you are hungry, but in the kitchen only one roti is there. One roti is present. You can eat 10 roti, but only one roti is present. So at that time you can't eat 10 roti. Only one roti is max you can eat. Suppose like that, at that time at 100 hertz, your only one data will generate. So if suppose there are something right, then you can read. After the write operation, you can read
Okay,
one
okay.
one data. Take this time period to write. Your clock frequency is high, so it's no matter what this another, like in this time period it will generate, but no matter what your rest of the, like only one clock cycle is working, I think. Sit. Okay. Only one clock cycle is
Okay.
working, and rest of the will not take any data. अरे भाई क्या हो रहा है? पता नहीं। वो अच्छा वाईफाई बहुत लो हो गया. Got it? This concept. Ayush,
Okay. Now clear.
hello. The guy was sleeping.
Oh, sorry, my mic was off. Yeah.
Yeah. The concept is clear, right?
Mm, little bit means,
Confusing, still confusing, right? Okay.
yeah.
Okay, I will tell again. This is one of the best questions. Log A. Okay. So there are some relation that my clock is frequency is 100 hertz that I assume. So my clock B frequency is 400 hertz.
Mm.
Yeah. And what is enable time period? Enable of B, there are some relation. Enable of B is something time period of clock A into 100. Time period of clock A is what? That is 1 by 100. Time is 1 by A frequency into 100. So that is 1 second.
Mm.
Total time period is 1 second of enable signal of this module B. And
Mm.
another said that enable of B have only 25% duty cycle. This part clear, right? Up to this part.
Mm. Yes.
Okay, now I draw the signal. Like first I draw enable signal. How enable signal look like? 25% duty cycle, so 25% and rest is like this. This is 1 second. Hello,
Uh-huh.
because
1 second.
yeah, 1 second. And this is my
0.25. 0.25.
0.25 second.
Mm.
Okay, right?
Because yes, 25% duty cycle.
Yeah. So now I what I do this my this time period is 1 second, and what my time period of clock be, that is 400 hertz.
Mm.
So 1 by 400 is what?
Wait, I'll tell you. 2 point.
5 millisecond.
Mhm. 2.5 minutes.
Snazis, Gaurav.
Yeah.
Yes, yes.
Yeah. So 2.5 millisecond. So this is 1 second, and uh, my time period only 2.5 milliseconds. So in 1 second, how many? Like almost 2.5 milliseconds. So if we multiply, so 1000. So 400, right?
400 around. 400 around.
So this is whatever the time period, like this time period, I would say. This time period. I mean, not this, but this. If we stretch this time period, something like that, you can see.
I can see.
Yeah. Like this is my total time of 0.25 second, or you can say 250 millisecond, right? Hello.
Mm. Yes, yes.
Yeah. And what the time period of uh, enable signal? The frequency 2.5 millisecond. So 2.5 milliseconds, something like
Mm.
that. Like I assume this is my 2.5 milliseconds. There are also the clock will be like very high, but for now, for understanding purpose, I just only assume that this is my 2.5 millisecond. Although like geometric wise, it's not look like 2.5 millisecond, and it is 250 millisecond. Okay, this is my second, something like that. And what is your writing speed? Suppose the other clock I will
One.
take Okay, this is like dot dot something. And what is your
Okay, just go upside. Can you scroll up?
yeah
Okay, okay. It was like 1 second. And then how that value came?
what
Which
value?
one?
No, not that. Scroll down. Scroll a little bit more. This 250. Okay, 0.5
Yeah,
was there
0.25
now.
second. That is 250 millisecond.
Okay, okay.
So here it is 2.5 millisecond. And what is the time period of this? 1 by 100.
Angred.
So if I 1000 multiplies,
0.01
0
so
point.
10 milliseconds.
10 millisecond, right?
True.
So here, this is actually not 250 millisecond. It's like very less. But we can do one thing. So just remove this and just like entire because it's very high, right?
Yes, yes, yes.
Yeah. So and we what we can do? 10 1 2 also. Yeah. So this is my
Hmm.
2.5 millisecond. This is 2.5 millisecond. This is another 2.5 millisecond, and this is another 2.5 millisecond. So total tone 10. Here also total 10. This is my write speed. This is my read speed, like read clock, or this is my enable.
Okay.
Now I am saying that
Name,
at 10
name
millisecond time period, I will write only one, like
One data.
one data.
Hmm.
So how you can say that you read max to max only one data? Because at the time period of 10 nanosecond, your data will generate only one. If
uh,
your writing speed is like you can write only one data, then how you can read 10 data? I mean 4 data. That's not
uh,
possible. If you not write, then you can't read. Suppose this white blank space. Can you tell me like what can you read here? What the like you can read. Got it? Synthesis.
Yes, yes, yes.
So only mm, up to here. Sorry, not up to here. Uh, you can only read one data. So this total data is 10. I mean 250 millisecond. My enable signal is high. On that time only can you can read, and rest of the at 250 milliseconds. So how many data will you can write? So 25 because 250 by sorry you have total spend
100.
how many 100 into 10 millisecond.
Huh.
So your
So
total
it
is
will be
1 second.
1000 milliseconds.
I mean
Hence
1000.
one.
Let's
One
suppose
second.
into 1000 millisecond. So this
Huh.
total much time required. But what we see that 10 millisecond your data one data write and one data read only. So in 250 millisecond total enable time is 250 millisecond. So at this time only you can read 225 data. Okay, and rest of the 750 millisecond your enable time is off. So 75 data can't
Next level.
received by module B. So obviously FIFO depth is
75.
75. I think this will be the answer. Must be the answer. This 75. Gaurav, Ayush, Synergist.
Mhm.
Good, bro, I got it.
Ah, got it.
Wonderful question, yeah.
Yes.
Yeah.
The question was very great.
Good question.
Yeah. Okay. So what do we do next? Because almost all the this
No,
also be one
bro,
of the
discuss that question.
which question?
That technical words question is there now. If you are
Technical
ready,
byte.
then
Yes.
okay. I discuss.
DGQS.
Not DGQS, that technical bad question. Okay, let me show. Okay, just
Yeah. There's a share your skin.
ठीक है?
Gaurav, share your skin.
yeah, yes, yes.
What happened here? So yeah. 10th number question was like totally different question. It was.
Visible, huh?
Yeah, it's visual.
हाँ इधर से इधर
Synesis कुछ दिख मत देना, ठीक है? So, you can.
Hello.
yes.
Yeah.
The
We
question
can
is in
see.
like frequency is 80 megahertz and modular frequency is 3 megahertz. So
Yeah.
the first line is there, like it's not there in English. Like the first line is when you are when your FIFO is like continuous signal. There are no bursts. Like your data is directly continuously signal only. Okay, no any burst size. Okay. So when like in the FIFO, if your data is going digital, like sorry, continuously, no like in the burst, then our digital design then our design is not not able to read or write, because it will get corrupt only.
Yeah.
Because if the data will come in size, then only before our design will able to able to work. So in the question, our data is data is coming continuously. Okay, so our design will correct only. Okay, so the main question is when our FIFO depth is 124 byte. Okay,
Hmm.
and there
Okay.
and there are some like duty cycle of write enable is 50% and duty cycle of read enable is 25%. Okay, this thing is there. So main question is like what will be the first data byte lost in that incoming stream. Just like in the before depth 1024 byte is there. Okay, before is 1024 byte is there. So what is the next byte will like corrupt only. So many people think answer is like 1025 bytes only, but it's not the correct answer, because like your data is stored in that FIFO. Okay, and at same time of some data will read by that module A. Okay, got it?
Yeah.
So which bit is correct, like next bit is correct. You got my question. My English is not good. Okay, please understand.
It's okay.
That's why
Okay.
we are like try to speak
We
in
are,
English.
we are,
Our
I
communication
understand.
skill is not that much good also, Gaurav.
Yeah.
Yeah.
So okay, so like I am
Where,
like any like digital network.
Bro,
Yes. Uh-huh.
bro, you are the seer of NIDT communication system. You handle
So
so many professors, bro.
So like
okay.
that the next image is like the answer only. Okay. So if you guys if you guys are like discuss something, then you please discuss. Okay.
Yeah.
Next
Let's
image is
let's
No,
the
but
discuss
answer.
this question.
one doubt in the question, bro.
Uh-huh.
doubt is like now the we don't have the burst size, just data coming like one by
Continuously.
one.
One
Ah,
by one
okay,
continuously like
okay. And the FIFO depth is 1024 byte.
4
It
bytes.
is it is
It's
given
given
in
in
question.
It is given in question.
Okay,
Okay,
let's
now
try.
we have to find out.
then
Like which
what
bit?
is
What will be the first data byte lost in the incoming stream?
first data byte means?
No, no. Let's
Means
see. Like when our like module B frequency is high, okay, and your module B frequency is low. Assume there is no FIFO, okay. Assume there is no. Then what we'll do? Then what will happen? Like module B is continuously due the data, okay. And if a module B is like what until it capable to read, that time he read. Okay. When its capacity is like goes above, then it will be correct only. Like this data is correct only. Okay. So we have to introduce FIFO. FIFO 1024 bit width. Then what happen? 1024 bit data will store in FIFO. That time only module B is reading some data only. Okay. And but at that time, like the time is like that time is surely will come, then the data will corrupt because uh, because module B is frequency high. He is
like,
continuously throwing the data.
Okay,
can I
got it.
explain once? Like, what is the question?
Sir, sure.
I got it.
Yeah, explain it more
Like
clearly.
means there is two frequency there, and FIFO depth is constant here. Where in the previous questions we are calculating FIFO depth to disable the overflow or underflow. Now the
Okay.
question is that FIFO depth is there. Now we have to say that in which byte, like how in the number of byte came, then the overflow will occur.
Okay. Like eight. Hmm, hmm, hmm.
Do you understand now
Uh,
that
how you are
like
concluding that overflow is occurring? There can be underflows
because
also.
Because that burst size is not given, so the data is like continuous. When the data is continuous, then surely overflow will occur.
uh,
Oh, is this any condition or something?
no, you can predict that 1 minute, 1 minute,
No, it's
one
not
minute
about
will come.
condition. Like uh, if it's a continuous data, it is matlab,
Oh, if your data is continuous, okay,
okay.
uh, then at that time will surely come that your FIFO is full because the data is continuously only now. Let's
You
take
need
like
infinite memory. On that PDF in starting they said if you're
Ha.
like not sending the your frequency like high, sending end frequency
Hmm.
is high but receiving end frequency low, but if you send the data in continuous way, so
mm,
no FIFO depth will be like
no FIFO.
working as a like there are some
Mm,
infinite FIFO depth will be
Yes.
required to store
yes.
some
Okay.
data. So that's why there says the burst word. Burst means at some time you send like your clock
Data
is
and
working very highly, or data will generate very high, and after some time your data like not generate. That type of question will be there. But here the continuous way to generate at high speed. At high speed, you generate the data or write the data. So at a certain time that your FIFO depth is totally full, and whatever the data that will overflow, you tell the that number like and which time or which period that data will your overflow, because at the same time your read operation will perform. So whatever the write operation that previously did, so if the read operation perform, so you can like at that particular block you can also do the write operation again.
Okay. Okay.
Time taken to the write one data byte. Okay, I will try to explain. One by write data.
Now I'm
Yeah, you can also. No issue.
Everyone try to solve first. Then
Yeah.
No. First like
you
I
have the
completely know na that what is question.
now it is
Which
okay.
no, I usually go.
Yeah, I got it.
Now we can like so this thing I think did come like double the time to write one data.
Mm-hmm.
Fine.
2024.
Hello?
Yeah.
Yes.
Acha. Okay. Nothing is moving now, or no one is saying. Or
Okay.
So let me show the answer, right?
Wait. Just a second. I'll try.
हाँ हाँ
Try.
इस क्वेश्चन को एक और तरीके से समझ सकते हैं मतलब आंसर के मैं नहीं बता रहा हूँ क्वेश्चन है जैसे कि
Hmm.
अज्यूम कर लो कि जैसे कि स्नेहसी से 1 घंटे में मतलब 10 रोटी बना रहा है ठीक है
Hmm.
और मैं 1 घंटे में 5 रोटी खा रहा हूँ ठीक है क्या हुआ बीच में एक पड़ा है मतलब अपना रोटी रखने वाला पड़ा है कुछ ठीक तो इसने स्नेहसी ने 1 घंटे में 10 रोटी बनाई उसमें रखी ठीक है और उसी 1 घंटे के अंदर में मैं 5 रोटी खा के लूंगा फिर दूसरे 1 घंटे में वापस से 10 रोटी रख देगा और मैं भी वो रोटी 10 रोटी खा नहीं पाऊंगा एक साथ क्योंकि मैं तो 5 ही खा रहा हूँ ऐसा कुछ मतलब एग्जांपल से
We
समझ सकते हैं
now we can do like that only. Like we have to calculate the first how much time it will take to write the data, and then we can just iterate it and do the down sample like that only. Like for 1024 bytes, we have taken the time to write in this FIFO. It is 25,600 nanoseconds. But in 25,600 nanoseconds, we just only read 320 data. So we have to just downsample these things to calculate this in which byte, in how much second or which byte the overflow will occur. It will less than 1024 bytes. I think the answer will be
आंसर भी लेस देन
1024 bytes.
हाउ इट्स नो
Oh, sorry. No. It will be greater than 1024
greater than
bytes. Okay.
20 because
Ah,
after
it
25
will
minutes
be
people only
1 minute. 1 minute. Answer is something 1600 to in between 1600 to 1700.
600 to
I am
7
getting like that. Ah,
no
I
but
don't know actually, but
mm-hmm. But SNES is just next thing now like before depth is like 1024 bytes okay so 1024 bytes like 1024 bytes, even FIFO only is able to able to store now. How it will corrupt? Would it have module B send one data? Okay, FIFO depth will store it. FIFO depth, then module B will okay that read. Sorry, module A will read. Again module B will send one data. Again module A will read. So like as of now, 1024 bytes surely data module A will read definitely because that depth is storage element is there now.
Okay, now what you are saying that we have to calculate like that. In 1024 bytes, it has written there. Clock B has written there. Now we have to calculate how much data will be read in that time.
That time.
Okay. Now we have to minus that, and again we have to calculate that much data have to
That much
written
data.
in that time.
Ah.
Okay.
Right. Right.
Okay, now I got it.
Three 3276.
3,126. Here's no, so it's a
Hello.
1 minute, 1 minute.
no, bro. Vallabh bhai,
Yeah.
3,000. 3,000 is not correct answer.
2000.
Hi, 2,000. No, why do you try like Vallabh bhai? Why do you try? You can explain like why do you try? Why do you think like?
Huh? Sorry, what your question?
No, like how you like what you thinking like how you get that answer 2,000? How you got this answer?
No, 2000 is
1,000.
not answer. Like my answer is 3276.
3,276. Okay, it's not the correct answer, but how you got like what are you thinking? I'm telling you.
Okay, I am thinking that at 25 nanosecond you write one data, right?
Huh.
Okay, and uh, at at the time of 18 nanosecond you can read one data. So one the way you just write one by one data, and at the same time you just read one by one data. But the read time is very high, 18 nanoseconds. So
Mm,
at the same time you write 25 nanoseconds. So almost you write three data and you received only one data.
mm, Sure. Yeah.
So
Right.
so almost you just write around 3000 something data,
But
3276 data that
but
time.
bro, FIFO is there now. Yeah, that's why FIFO is there. So
Yeah,
when you write data in 25 nanosecond, okay, then it will store in FIFO. Okay, then you will read it from FIFO. Okay, so is this process continue till that FIFO is like full?
yeah.
So no. Now that when FIFO is full, okay,
Hmm.
then also after some bits, like that module B will read some data. Okay, then it will corrupt because the data is data is 18 nanosecond now, and its write is 25 nanosecond.
Yeah.
So you assume first FIFO depth will full. Okay, so till 1024 bytes it full. That time that module B will read. Okay, after some bits also, module B will read some data byte. Okay, then it will be corrupt only. So your approach is like good only.
Okay, so
You can
what's the
you
answer
can try
actually?
with you can ask Mr. Thomas direct. So that answer is like you just assume like that after that 1024 data stored in FIFO, then like module A will read some data like and after
Okay.
that fulfill that FIFO, then you assume like our module A will capable to read some data. Okay. Then some data means n. Okay, n. So like module A will how much time take to read data is like n means like that by into whatever one uh, like one read it's like 18 nanosecond. So total time is taken by 80 into 9. So this time is like what? When FIFO is full, okay, then some data will module A will read. Then the time is this. Okay. So
Got it, got it.
module A
Shift.
will give how many data? 174 data that is stored in FIFO and additionally N data. So that can
Yeah,
module
it's a
A can
nice question.
one. So like your N is 466 only. This is not the answer. You have to add on this like 102 data bit only stored in like it is like so next data is like for one, 1049 491.
Yeah, got it. Nice question.
Nice.
Yeah.
Second is not good, but I think self-explanatory.
Gaurav, sometimes like most of the time your audio is breaking.
Okay. I think my Bluetooth
Everyone
is off.
feels the same, right?
Ah,
It's Sana She's audio. Okay.
Okay. I will check the
I
mic.
no, I think it's Sana She's audio.
No, yeah,
I
Gaurav is
am not
speaking, so
talking.
No, no, no. Some background noise comes always. I think.
Okay, okay. I think it's from my.
Uh, uh,
Okay, this is problem from like background or earphone something. This question
no, no.
question code na.
Yeah, we got the question
yeah, that was a
actually.
nice question.
Yeah.
Actually, I
Like,
did the calculation
Gaurav,
mistake.
what?
Yeah, your approach is correct.
Okay,
Okay,
so
if you
any other
want like
question?
that, I have no. This question only. Rest of the
Okay,
question is from that PDF only. This question is
oh,
only different.
okay, that was a nice question. So what am I saying that we'll discuss STA problem or yeah, first discuss STA and then we will go to the like CDC. CDC is one of the like uh, good topic that definitely asked in interview and also like CDC and the FIFO. Previously, we just discussed the FIFO depth concept, but why FIFO is important for uh, log domain crossing and how the FIFO concept came for solving uh, write and read version, how it's solved. So that concept we will, I think, we'll discuss. Then it would be better.
We complete that FIFO session, but I have one doubt. Okay, like the doubt
Mm.
is like FIFO is two type. Okay, synchronous FIFO or asynchronous FIFO. Okay,
Yeah.
Yeah.
synchronous FIFO is like
Focus.
okay, somewhat I understand like that clock read and write clock is different. Then we use asynchronous FIFO.
Yeah.
But that synchronous FIFO, if the write and read is like clock is same, then what is the need of FIFO? Like if we are like giving the data and read the data in the same clock, then like our work is like over now. Why the need of FIFO that time?
Okay.
No,
So
like I'm thinking like FIFO is
can I
Yeah,
used
tell?
yeah,
when
yeah. Yeah, I got it. Yeah, Pallab, go ahead.
no like first now like I'm thinking like FIFO is only that we have to use whenever both module have a
The
different
cloth.
yeah.
Ha.
That is only the clock
Act,
domain crossing only. That is
act,
only the
Okay,
clock
uh,
domain
I
crossing.
will explain. I think I can.
Uh-huh.
Yeah. My screen is visible, right?
mm,
Yes.
So your synchronous FIFO. So that is one pipeline concept. So
Okay.
suppose here some operation is done. It's a like combinational block combo. And here is another combo. That data goes direct to here combo. Here is another block combo.
Okay.
That is also good. Suppose this would take 8 nanosecond. So suppose 8 time unit, 8 time unit, 8 time unit. Every combo. Combo 1, combo 2, combo 3.
This is the
And
combination logic. है ना?
yeah, just a second. Uh, so can you tell me how, like, if you suppose one instructions goes from here to here, how many time it would take?
24 minutes.
24 time unit. But suppose we'll between them, if we suppose some register block we will take, like it's a like
Uh-huh.
pipeline structure,
Mhm.
and we will provide the same clock to every, it's like register type. Can you tell me now how many time it would required, like the new design, to perform better way of
I
person?
think 16 hours.
Uh,
16 hours, I think.
like
eh,
here also present, here also
First,
present. Tell me.
now I think 8 only. Because
8.
that computation logic will give the half.
Yeah, 8 in so. So this is nothing but this is register. It's called also FIFO. Fast in, fast out.
Okay. 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 Okay.
This is nothing but
The
FIFO.
logic. Mm-hmm. Register is mean.
This is like your data, whatever the data goes fast, that also goes out fast.
Mm-hmm.
This is FIFO, nothing but it is FIFO. And another concept is, suppose yesterday we discussed one a very good concept. Suppose your module A and module B. Here like module A, module B. Its frequency also 30 hertz. Its frequency also 30 hertz. But still there is one FIFO is required here. Can you tell me why? The concept is 30 hertz. 30 hertz, suppose something like that. Okay, just a second. This is my 30 hertz of F clock A. Suppose clock A, it's 30 hertz. And the 30 hertz of clock B is something like that.
Okay.
Part difference,
The
phase
phase
difference,
difference.
phase difference. Due to this phase
It
difference,
also 30 hertz.
Sure.
It also
It's
30
clock
hertz.
frequencies, but okay,
Yeah.
That
But
that
the yeah,
yes.
here also 30 hertz, here also 30 hertz. But the phase difference is different. So that's why we need FIFO. And this is called
synchronous
also like
people.
synchronous FIFO. And also, why this is also it is connected. But there are some skew. Like if you read the clock tree synthesis, like in physical design, from
Yeah.
here to here, there are some wire delays, uh,
Skew.
yeah, present. For that
Mhm.
skew, this kind of things is happen, phase difference.
Mhm.
This is same clock. You provide same, but it's reached after some delay. So that's why like skew is not that much good.
Okay. Okay.
So that is also FIFO.
Okay.
This is why like I am telling that this is all I try to say is that clock domain crossing problem, nothing but.
Uh-huh. Echo and synchronizer, that both are solution of CDC.
Yeah. So now I explain. Anyone have any PDF of STA
STA
question?
PDF, huh?
Yeah.
Yeah. Question PDF.
Yeah. Or
I
STA
have
PDF.
that. Uh-huh.
You can
No,
share also STA PDF. Share with me STA PDF if you have any. Or let me search on my placement. Some STA.
Yeah, it's there.
Let's see. Okay, there are STA. Okay.
My God. STA PDF means like question you want, huh? Some good question or something.
Yeah, also question and all the things. Keeping. Okay, I will tell.
One
No.
website is there, like
VLSI.
VLSI point or something, like one website is there now
Okay.
for this STA topic.
Hmm.
I exactly forget the name, but I will check. I think I have. I will check and share with you then.
Okay. This some kind of notes. I think it's from Himanshu Agarwal, probably.
Ah, yes, yes. Himanshu Agarwal. This, if anyone have the course, then he or she can download it. Gaurav, do you have the course of Himanshu Agarwal?
Mm-hmm. Ranjan have
The,
received it. Notes we will.
Metastability. This is actually STA plus CDC.
Okay. No, you are guys from from where you study that ST? I learned that from YesGen.
Yes, Gen also good, bro.
Yeah, good.
Yes, Gen is good.
I
Actually,
think
I'm
I think
I'm
I
not
have that.
watching, but watched yet. But my senior all learned from Yes, Gen.
But it video is like it wants some
Very
basic
short.
concept already.
Very short.
Yeah.
Short, but it bro, it's not short, bro. One video is 7 minutes only. But if you but if you like just go to deep now, then it will take more time because its videos like that. Seven video, 10 minutes. But really, it will take so much time.
Okay. I think I can teach and explain. Okay.
Yeah, I think this is similar to EHN videos.
So this
Yeah,
will
Himanshu
be
Agrawal has taught this STA in 3-4 hours, I think.
yeah
No?
the same thing I will tell you.
Okay, okay.
but if you go to those video now, it is not like for the preparation. It is just only problem solving. He didn't tell about anything, this logic, how this setup time came, how this whole time came.
Who-
It is
Whose
asked
Yeah,
in
name
yeah,
is
yeah,
interview.
whose name is it? Himanshu Agarwal, huh?
Himanshu
yeah.
Agarwal, yes, yes, yes.
Okay. That's it.
If you
That's
just
it.
no, no, if you just want the basic structure, like in the gate level, how this
Mhm.
setup time, hold time came now, then you have to go through this Janki Raman
Yes.
playlist, last 13 video. It's it's only the prerequisite of this STA. It is very important.
ओ बट भाई यस
Yeah.
ने भी अच्छा पढ़ाया थेसिस भाई उससे पूरा समझ में आया भाई
Yes, Jen is also good, but if you want to know in the basic structural level and do this,
Mm.
how this work, how this flop will work, how this or latch will work, then you have to
भाई
go
सब
to
पढ़ाया
this. Yes,
भाई
Jen is
से सब
also
पढ़ाया
okay.
भाई
Yes,
लेच कैसे काम
yes,
करता
Jen,
है
I know.
नोड एक्स सब पता है उसको
Okay.
Yes, Jen is also good. Okay,
You
let
are
me.
recommend Senashis, you are recommending Janki Raman for STA.
Yes, yes.
Yeah,
No, no,
Janki
no. I
Raman
am not
last lecture
recommending Jain Channel.
he is like
क्या?
telling about the digital IC design part where you find like what actually the flip flop is working and how your like latch or flip flop is violated and what is set up and whole time they said the concept how it's affect your
Okay.
circuit.
Okay,
Like
the
if you
last
want
lecture.
anyone ask you that
Last sequential circuits lecture,
that
no? Last 3-4
ah
lectures.
हाँ हाँ
Uh, 30 lectures is there, I think. Like if anyone asks you that if given a circuit in the mux level latch or mux level flip flop, not a conventional flip flop, and ask you to write the setup time or hold time, then you have to write now. Then you go to this concept that what is the setup time of the what is the
Mhm.
whole time of this.
They just
That's
do
why.
the transistor level module. So transistor level module is
Uh,
it is tough actually. Here I just want to set the some numerical problem that you can solve by watching Himanshu Agarwal video. But that is not enough for concept point of view. That is for purpose
Mm.
like gate exam. Gate exam there are some HTA problem comes and you just do the numerical what he teaches. That is the perfect for numerical point of view. But when it comes
Mhm.
to the concept, his concept is gone.
Mm. So where can we learn STA? Like I have not watched anything for
Okay,
STA.
so for
Basic
now,
I know. Basics I know. Like yes, Gen I have watched. That's it.
If you watch it
I
yesterday,
think it's also enough.
enough only. Na. You just practice question, bro. I was
yes,
like, I
Thing is
have
that
that sufficient technical bites. It have 22 videos of interview question only. Okay, 22 videos of interview question. You directly watch that video. Okay, it's very good
Okay.
only.
ah,
Yeah,
it's okay
Technical
if
wide.
you
technical bite. But
just
some videos is for for members. Okay, I think four or three or four video, and that three or four videos only very good only. So if you want that ID password, I will share and just to watch.
Okay, okay.
Businesses, if you want, then okay, I will share with you all.
okay, okay. After
Because it's
when I
three or four videos very good only. You saw the example of people now. Its question is very good now. For this
ah
question is for technical bad only. Same type of question, like very good question.
okay, after coming to hostel, I will take password
Yeah.
ID password from you.
Again, I will
No,
try if you
first
want, then I will
yeah,
try.
for sure.
If you want, then
Yeah, I'll dim you and I'll
yeah.
dim you.
Okay.
You are not in hostels, Anashish. Are you in
No,
you are
I am in
like
home now.
Yeah.
so you are in
Home Bangladesh, Bangladesh.
okay.
Hey,
mm, okay.
Like
एक्सपेक्ट
So
अपने भी बंगाल से है क्या?
हाँ हाँ दोनों
अरे अरे अरे
बंगाल से हैं।
गलती हो गई मेरी।
यार so what is the internship scenarios in NIT Trichy? Like
This is why.
2 month.
internship is like if you if you
two
go
months
to
बोला है
other
मतलब
faculty, it
हाँ,
is only 2 months, and after
okay.
this it will be 6 months plus FT. But
हम्म,
in this 2 months, if you go to this what is called is industry, then it is okay. If you do under any ma'am or sir, then like you have to do your own. I am doing my project in my own only. There is no one to help, and my guide is also from communication, so it's
oh
very difficult for me.
Can
मतलब
we wait? Can we
two
Ah,
discuss
months
like FIFO
internships
problem
Okay,
okay
okay.
for sure.
tomorrow? Like we'll discuss in transistor level. For now, it's like
Okay, okay.
circuit level
only
or
concept circuit.
okay. So this is my D. So data is here present. So D is like I assume like whatever the problem if you want to solve, assume that this data is always stable. Suppose this is always one. So this is always stable. One means high.
Mm,
Okay.
mm,
And what's the time period that we calculate? That is also my time period, or you can say that would be the maximum frequency that we can achieve.
mm.
Okay. So suppose my
Like
clock period is this.
maximum frequency of clock.
Yeah. And that we want to achieve by solving this STU problem.
एक मिनट but clock frequency is like inbuilt ना you can't
Inbuilt means
change or
you are
मतलब
uh,
it's already set ना मतलब clock
how it is
frequency is
set.
already
No, the clock will set that there are some all that delay they count and after that they set the clock. It's not like before they like without uh, any mathematics without they are using they can't use the clock. That's why there are particular HTA team is present. HTA and synthesis team is present in every company,
mm,
every semiconductor company.
mm,
Yeah. So this is my clock and this is my time period, right?
mm,
But
mm,
what's the time period of this clock? How we can uh, say that it's like uh, its time period maybe 100 hertz, maybe 100
okay,
sorry 100 nanosecond, maybe 200 nanosecond. How we can say?
okay.
So this is my another flip flop, like one flip flop,
Mm,
and this is another flip flop. So there are two flip flop, and you want to send data from one flip flop to another flip flop. This flip flop name is uh, launching edge flip flop, and
okay.
this is accepting the data. So this is called your uh, I think
Capturing edge.
capturing flip flop something, capturing flip flop.
Okay. Mm,
So your main motto is you want to send data from uh, this flip flop to this, right? So
mm,
there are some delay will be present. So
yeah,
this
propagation
delay,
delay and
something like
clock,
this flip
clock.
flop delay is
Mm,
something TD also present, T clock to Q delay
clocks
also
Q.
present, and T setup also present of every flip flop. This is
Mm-hmm.
some data list you find like every flip flop here and here also. For this case,
Mm,
I take TD, TCQ, T setup are same, like not same, but
mm,
for every flip flop, TD is same for every flip flop. TCQ is also same for every flip flop. T setup also same. So
mm,
at that time, we see your data. Data is always stable. So just at the point of clock, like clock age, we see,
mm,
and there are some setup time and hold time. Setup and hold time
mm.
is something that in
Uh,
between,
Before the clock and after the edge of that clock, no? The
but
data must be stable.
yeah, data must be stable. So minimum period that data must be
Mm.
stable. Data should not be changed either 1 to 0, 0 to 1.
Okay, okay. The minimum is the keyword.
So this period data must be stable.
Mm,
Here here change also not a problem. But if here
mm,
it is changed, then it might be problem.
okay.
So in this case, my data is stable. Okay. This clock
Mm,
is goes to everywhere, like this flip flop and this flip flop also.
mm,
So there are some um here before that no clock is present. So my output of D flip flop is zero.
mm,
I assume there no data is present, so it's I assume zero or we don't know. It's like we can't say. So after some time, after this clock came, there will be some delay will be present. Suppose this is my delay. This is my TCQ. TCQ is something that after clock came and uh, how much time later, like what's the minimum time later, or like what's the maximum time later you find or you get the output data of this flip flop. Suppose this is Q. So this is your Q. And this time, this is the delay. You got the output something like that. Again, this clock came, but that time also it says that uh, setup time and hold time is not violated. So whatever the previous data, like if it is zero, then obviously it goes down to zero. But for now it is one, so it's one.
mm. Okay.
and this is my clock to Q delay. Clock to Q delay is something that your clock came come, and
Uh,
what the
and the
delay
data of time taken of the
data
data
will propagate
to
from
transfer
input to
to
output.
D to A, D to Q. Yeah. Okay. Yeah, I got it.
Yeah, and this is your TCQ. And now there are some combo,
Mm,
there are some combinational block. Here
okay.
some delay will be present. So T combo I
Mm,
said, and here I
mm.
name is D2.
We are not considering whole time.
I will say later why whole time, why
Okay.
not. Just give me a time. So TCQ. So what is
Okay.
my D2? D2 is like
Mm,
this will just follow the combinational block. Suppose I am taking the buffer. Buffer is what is did
mm,
that it will generate the same input, but it's at some delay. So it's
mm,
suppose another like that.
mm,
This is your data that at that
mm,
present at the flip flop. This flip flop at D2 that is present.
mm,
So that is TCQ, and here is T combo. This
mm,
time is TCQ and this time is T combo.
mm,
I mean, this would be must be same. And
yes.
the next clock is coming. So your first clock is done. First clock is like at that time this will propagate this data to here. Again combo delays happened, and again its data goes to here. So there are some here also the clock will come. Next clock goes to here also and here also. But we'll see the receiving point of view. If the my at this time my data uh I say like uh the at the launching edge my data will generate or data will uh propagate from this flip flop. Then obviously the next clock cycle it will receive the data from this combinational circuit or this entire circuit. It will take the data.
Mm,
So at that time it will see the my setup time that is necessary, not whole time. Here whole time is not necessary. Though whatever the setup time of flip flop, so that is some setup time. Like we can say this is my clock, something clock. So this is my T setup of flip
mm,
flop. So what is the total
mm,
frequency of that, like maximum frequency uh, of that circuit? That is like my maximum clock frequency that circuit will operate. That is first we the time period we needed. The time period is something greater than or equal to of TCQ plus T combo plus T setup. This is the entire time period of the uh, this clock. It must be okay. Otherwise, what
okay.
happened if suppose T is less than or something like not
Mm,
fulfill that this,
mm, mm,
so
mm.
probably your like not less than something,
How? How?
probably your
Mm,
circuit will not working, circuit will violated some setup or hold violation, most
mm.
probably.
Hold is not in the this equation. How hold will get violated?
Okay, so this TCQ is either TCQ is like greater than equal to T hold in most of the case, and in every even in flip flop also. And I will tell what is hold and where is the hold or delay will be like performing. For now, T clock is something like uh, time required for the operating this these two flip flop.
Mm,
The
mm,
time has T must be
Like
greater than equal to TCQ, that is clock to Q delay of first flip flop, then T combo, that is the my combinational block delay, and T setup.
mm,
T setup is for
mm,
uh, setup delay for flip flop 2. This.
okay. Mm,
So this is the like minimum time required.
mm.
This must be required. Your time you can add more time, but below this time, it's problem. Your circuit will be not working properly. So what is F? F is nothing but 1 by T. So maximum frequency, that is this. You can't maximize below, like after 1 by T. And what is hold violation and what is setup violation?
I think that is the minimum time and that will be the maximum frequency. है ना?
Hmm, it is the maximum frequency, and
हाँ,
this
it-
time
time
this
will be
time
minimum
Minimum.
time. है
Yes,
ना?
yes.
this is
हाँ.
not, this is the maximum time, I think.
No, no, no.
No, no. This is
The,
the minimum time. हाँ.
no,
Yes.
listen. This is the maximum time required to operate the circuit. If
No.
suppose,
Circuit can be operated in
हाँ,
maximum time. Like say if this t equal to 10, we can maximize 20. Then our frequency will be less.
हाँ,
Not a problem, na?
हाँ,
yeah, sorry.
हाँ,
This is the
हाँ,
minimum time.
that, yes.
हाँ.
Yeah, and please tell about that
No,
whole
yeah,
why didn't you
so you are thinking
like,
another way. This is the maximum time, I would say. Maximum time means something, you can minimum that time. Suppose T is equal to 10.
uh,
So below 10, it is not possible to operate the circuit. For what I say.
Okay, okay.
So this is the 10. That is the maximum time. This is the, like suppose you minimize the clock so time period. This is not possible. If 10, then 10 or more than 10 time period is required. You can't minimize the
So, okay.
time period.
Okay. What you are, this is the thing that you minimize the time, then it will be violated. If you maximize the time,
Yeah,
then it will not violate it.
yeah, it's not an
Then
issue.
it should be the minimum. Na?
Yeah,
Okay, this is the conventional thing. Like we can talk like that. That this is the minimum time that that is required, or it is the maximum time. Uh, uh, After that, we can't reduce the time.
yeah. You can say, uh, you can minimize the time if you're like it's already some 10 nanosecond will be 10 nanosecond will be there, or if you like minimize, then circuit will not work.
Ah, it is
So
just the convention, nothing else. Okay, okay. Concept is okay.
yeah,
minimum है ना वो time.
हाँ बोल सकते हो, like yes, minimum time, you can say that. Below this time you can't minimize your time, so obviously it's a minimum time.
Ah,
Mm,
Yeah. And what is hold violation, and how it has happened, and
mm,
so hold violation concept we will see.
अच्छा,
So
अच्छा, अच्छा, go to that. चलो ठीक है. Continue.
if one clock, okay, suppose this flip flop some whole time, like every flip flop 1 and flip flop 2, this is also flip flop, there is buffer, flip flop 2, flip flop have some hold, like here's the data sheet, hold time, suppose your 5 nanosecond, clock to Q delay, that is 10 nanosecond. And also the combo delay T combo, that's something uh 2 nanoseconds, something like that. Okay, so this is enough. So previously just D is the data, that is like D is here. So D is always high. Like suppose D is high, it's VDD something like that. Like in digital, you can say like 1, logic 1. This is logic 1. And your clock is something like that. And you see from here, posage clock. So what do you see that here your setup time is violated? No. Hold time is violated? No. Like hold time I will say. So this is like some minimum time will be required to not violated. No, it's not violated. So some delay and data will generate. So this is my TCQ. Okay. If TCQ is not that much high, suppose my TCQ is uh, 2 nanosecond, something like that. So what happened if it is 2 nanosecond? Then your data like that, your output like that. That is your Q. Okay. And also the T combo delay, we will add T combo delay, and suppose T combo delay is like that. The total delay is 4 nanosecond. But what is the whole time required? That is 4 nanosecond. Here you need 4 nanosecond time period. Sorry, 5 nanosecond is whole time. But your data output says that in this period your output generate at 4 nanosecond.
Why
So
nanos? क्या
4 nanosecond delay na, because TCQ T clock to Q is 2 and T combo is 2. Previously your T delay is TCQ plus T combo,
Hmm,
right or wrong?
hmm, hmm. That time is time period of clock, na?
Sorry. But it's somehow it's involved the whole time that you can see here, but somehow your whole time is present also here.
Like you have to subtract. If you subtract whole time in this equation, na, then it will get balanced.
Forget this concept now. Like I would say that
अरे यार.
what?
No, no. Continue, continue.
Okay, so your whole time is 5 nanosecond, but you will says that at the 4 nanosecond of time period your data will generate. So what happened? Uh, in
Like
transistor level, I
this
forgot
is Q
actually.
waveform. This is Q waveform or
I
clock.
I want to add one thing like
Uh,
this whole time is like if our data is not changed in between this 5 nanoseconds, then our flip flop will give the output correctly. But if data will change in this period of time, like in 5 nanoseconds, then our data will be corrupted. Now the data, this delay time is 4 nanosecond only, and our whole time is 5 nanoseconds. So data will be corrupted. So whole time violation will be there.
mm,
I think this is the concept
Yeah.
like that only.
right, right.
So your minimum hold time required is 5 nanoseconds, but within 4 nanoseconds, your data will change. Previously it was 0, now it's become a VDD. So it must that your circuit goes in metastable state. And what is the T hold time criteria? The T hold here must be uh, T hold must be less equal to your T combo plus of TCQ. This is the
Sure.
T hold, uh, you can say equation. Means T hold should not be greater than T combo plus TCQ, or either you can say T hold must be less than T combo plus TCQ. Hello.
Yeah, I'm listening.
Synergis?
In this previous equation now, this T equation now, what you have told now, that it is the very good point to discuss. Like T greater than equal to T setup plus T hold. I have solved two or three questions in the SPA in this equation, like T greater than equal to T setup plus T hold. But I just mug up this formula. I don't know that how they put this T setup plus T hold. Now I am clear that thing. Like, thank you for this clarification. It is good
Mm,
explanation.
nice, nice.
This T greater than T equal to T setup plus T hold. It is very good.
Yeah.
Very glad to hear that. Like, our motive is this only. Like, whatever the concepts are unclear, like, till the placements will clear the concepts. And
Hmm.
s- so, Ari Pallav, please tell me, like, why it is like less than and why, mm,
Because you can
why
see here.
are you considering this combination in TCQ only? There is one skew delay also, no? What is that?
Yeah, we'll tell skew later.
No, we
Skew will add later.
Okay, okay. Yeah, tell me.
Another concept is slack.
Acha, let's say, scroll upwards, bro.
Actually, I forgot to say one another concept, that is slack.
Okay, okay. Uh, just go upward after that.
Positive slack and negative slack.
Or okay, just go upward. I'll tell something. Uh, ok- at the diagrams of those flip flop. Yeah. Uh, let's say. Okay. Mm, make the Q2 also. Make Q2 also.
Yeah. Tell me.
Make Q2 also. मतलब mark that Q2 also.
That not that much important right now.
Okay. Now connect that Q2 to D1.
Yeah.
Now tell me what is the hold, what is the setup and
Okay.
just calculate the
From flip flop
equation.
2 to flip flop 1.
Uh,
Okay.
because for Q2 hold time will also consider मतलब will come into the picture na.
Yeah.
now we have to consider two paths and we
हाँ.
have to compare those two and get the
Hmm.
maximum path. That will be the required time. I think this is the approach.
Yeah.
Okay.
Before that, we will take here to here. Now also take from here to here.
Okay.
Now we have to consider these two paths.
And among
Mhm.
them, which is maximum provide the delay, we will take that maximum. We will don't take the minimum clock delay, because your minimum clock delay is working on maximum clock delay. Like if suppose this path delay is total 8, but here is 10. If you is take 8 time in a delay, like 8 nanosecond, here is 10 nanosecond. If you operate entire circuit in 8 nanosecond, then obviously when goes operation happened from flip flop 1 to flip flop 2, then your data will be like corrupted, or it goes to metastable state. But suppose the maximum is 10 nanosecond, and if you operate this circuit from flip flop 1 to flip flop 2 also operate 10 nanosecond, and obviously the clock will be same. So flip flop 2 to flip flop 1, when data will be generated same way, that also be like 10, then no issue. That's the time, right? Here is like 10, here is 8 and 10. So obviously if one is 10, obviously this also be 10. We can minimize.
I think one PDF is there. There are so many questions from this thing, this feedback thing only. We can
Yeah,
discuss. I
yeah, yeah.
will share the PDF. I think I
Uh,
have. I will share the
okay,
PDF.
okay.
Then we can discuss it by tomorrow.
Yeah, yeah, for sure. Just share those PDF in the common group so everyone will get that thing.
I
And
don't. I don't in the. I have no common group with you guys.
no, नहीं नहीं
Okay,
we
I
have
forget
found
to
one
add this guy.
play.
Actually,
अच्छा
I
अरे
forget.
add this
Yeah,
uh,
yeah.
add Gaurav and Sena, she's in that placement preparation batch. Okay, let's solve one quick puzzle na. After that we'll
हाँ
start.
हाँ हाँ.
Okay, let's just complete
Wha-
another like setup time and
This positive slack and negative slack.
uh, yeah.
okay, positive slack and negative slack.
Just
Yeah.
हाँ हाँ हाँ.
So I give you one example, that is a gate exam. So gate exam time period like 9 a.m. Like 8 to 10 a.m. That is the time. Like from starting, I think 9 a.m. it started, right? 9 a.m. it will started at morning gate exam. So this is like 8 a.m. This is 8. This is 9. It will start the exam. And in suggestion that everyone should reach at 8:30, like on and before
Mm.
8:30. This is 15 minute, another like 8:45. So what happened? One boy come at uh, come at 8 like 7:30. So he is eligible, right? He can
Mm.
enter the exam hall, and he can write the exam. So one boy come at 7:30, and another boy come at 8:15.
Okay, okay.
He is also eligible.
हाँ 9 is the closing time, no?
Yeah.
So
Now
everyone
one
is
boy also come at 8:30.
okay.
So he is on the right time. Like 8:30 is the the warning time or something like that.
Mm-hmm.
So he is in perfect time.
Okay.
But
Mm.
suppose one boy come at this time, like 8:45. So what happened in this time period? Your gate may be closed, the outer gate. So you don't know the guard will open the door or not. So
Mm.
might be possible your data is corrupted, or data will not at the flip flop age like setup time. If this data will like provide some delay, or like it's called actually basically it's a negative time, right? 8:30 and 8:45. So he's late by -15. Like he is late, or he is said he is provide he is like placed at minus 15 time of delay, 15 time of delay, or you said
Hmm?
he reach
मतलब
at the
he is
time.
15 minutes prior to gate closing time, no?
No, that is not, that is another concept. I'll tell you.
Okay. अरे यार.
uh, this entire time if the data come, then you can say your data might be possible that corrupted but not sure, but also possible to that are not corrupted. But after 9 p.m., after 9 a.m., if any one boy come and he want to give the exam, for sure he can't give the exam. So 8:30 was your warning time before which data came. That is comes under positive slack. That is called positive slack. And whatever the data between these present, that is called negative slack. And whatever the data that after also come, like your setup time is already violated, so that is called setup time is totally violated. So this is concept of positive slack and negative slack. Got it? Actually your delay like concept is something like that, your actual time and required time. There is some required time and there is some actual time. So if suppose the circuit is like this is a combo circuit and this is suppose different data path. So obviously there are some required time.
I
Suppose
think uh, positive slacks means like the time required number, matlab the duration of time before the closing of the gate. Like that thing is that.
yeah.
And है ना, if one person arrive at 8:45 and the gate closing is at 9, so
No,
it
no.
comes under
8:30
positive
is
slack. And
no. 8:30 is
let me come.
how? Your warning time is 8:30. On and before you
What
must be
is this
present.
warning time? What do you mean by warning time?
I don't know. Actually, the whatever the gate exam like one time will be there. I think it's 8:45 or something. 8:30 whatever.
Hmm.
Before you come you enter easily like your data stable then no issue, but after that come your data between 8:30 to 9, your data maybe you don't know at what output what data will get, you will get, you might be get corrupted data. But for sure if you like it's goes after 9 a.m., then you must be sure that you get corrupted data. Actually I have to also revise some concept, but this is the concept actually. Hello.
What I have studied in this positive slug and negative slug now, it is the simple definition of like required time minus arrival time.
Yeah.
हाँ
So
वही.
if
Required is
required
like
time is like
8:30.
8:30,
Required is हाँ
uh,
9, हाँ. Required time is 9.
uh,
ठीक है, and the person arrive at 8:30, so it's the मतलब 30 is the positive slack. That's it.
positive
No,
slug. So no data will be lost or no violation will be there.
I really didn't understand the concept of warning time.
Mm, okay, so currently I am also not recall the concept, but I will tell tomorrow. I have to like open my notes.
Okay, okay. That's all, Apazar.
Okay, bro. I'm going for dinner.
Okay, you are going.
Yeah.
Okay. So,
Okay, bye, Gaurav.
मतलब
mm,
like 9 o'clock we'll square it off, no?
okay, how much? Okay, okay. So this concept I want to leave. अरे यार क्या हो गया इसको? I don't know what's the problem. Actually, I write lots of thing in the iPad screen, but it will not show. I don't know. Can we go through one puzzle?
Like I
Yes,
don't
no
think
problem.
Okay.
I don't.
I don't have problem. Okay, then tomorrow.
Yeah,
Bye.
you're leaving.
No, no, no. I don't have problem. We can discuss now. But I will
Okay,
say now.
one puzzle. I use one puzzle. Just one puzzle.
Yes. I will hear the puzzle, but means like in Hyderabad, the mess close very fast.
Okay, okay, no issue.
Okay.
Then we'll discuss tomorrow.
No, no, we'll solve one puzzle. Just accept my call. I'll listen to your thing in the mess.
Okay, okay.
In the mess, but I'll listen to it.
Cheating husband. Else. Let's see this puzzle. Huh? Content remove.
Okay, okay.
This is some like family matter problem.
Cheating?
Cheating husband. See,
Husband.
Oh,
puzzle
so
name is cheating
puzzle.
husband. So I don't think some interviewer asking this kind of questions in the interview.
That's why it is removed.
Yeah. Okay, let's
If this
Microsoft
puzzles
problem.
come, na, you will be the topper of that. You will be the topper of that.
Camel and banana puzzle. I had you solved anyone?
Huh?
Yeah.
Camel and banana.
Yeah.
Yes, yes. I think I
Yes,
can.
yeah.
No.
I also solved this problem, but
Camel and camel and cactus are a good combination.
but somehow Camel
But
also
they
want
have
to
only banana.
uh, like Camel also like sometimes he have to mood like some party so that he want a banana. Like cactus is yeah, his daily food, but somehow like you, I also every
Mm-hmm.
day you are eating mess food, and some other day he goes outside and take some biryani, Hyderabadi biryani. So that kind of scene.
Hey, bro. Hyderabad, IIT Hyderabad is outside, like it's far away from the city, like 60 kilometers far away. I live
Oh,
in
okay.
some town, मतलब village type thing.
Okay, I will tell
So,
you what's the question actually. A person has 3,000 bananas and a camel. The person wants to transport the maximum number of bananas to a destination which is 1,000 kilometers away, using only the camel as a mode of transportation. The camel cannot
uh,
carry more than 1,000 bananas at a time and eats a bananas every kimis it travels. What is the maximum number of
mm,
bananas that can be transferred to the destination using only camel? No other mode of transportation is
mm,
allowed. Okay, I
mm.
don't know why this thing is not working.
Bro, explain it in Hindi, like because tr- I'm walking on the road.
Okay, हिंदी।
हाँ हाँ, अरे यार मैं चल रहा हूँ ना भाई रोड पे, तो इससे थोड़ा कंसंट्रेशन टूट रहा है।
ओके। 3000 बनाना एंड
बनाना है, एक इंसान के पास 30 दिन बनाना है, एक कैमल है, पर्सन। हाँ
1000 की में डेस्टिनेशन है टोटल।
हाँ।
एंड क्या किया,
अच्छा
एक किमी में।
अच्छा 1000 किलोमीटर दूर दूर जाना चाहता है कैमल के साथ, ठीक है। बट कैमल तुम्हारा 1000 बनाना एक बार में ले जा सकता है, ठीक है।
हाँ
और वो पर किलोमीटर तुम्हारा एक बनाना खा जाता है कैमल। तो समझ रहे हो, 1000 जाने में और 1000 खाने में, तो सिर्फ वो 2000 ले जा पाएगा, ठीक है। 1000 तो वो खा ही जाएगा रास्ते में, ठीक है। व्हाट इज द मैक्सिमम नंबर ऑफ बनानास दैट कैन बी ट्रांसफर्ड टू द डेस्टिनेशन यूजिंग ओनली कैमल उधर। ओके।
ठीक से
मतलब वो आने के
सुनो।
टाइम में खाएगा नहीं, सिर्फ जाने के टाइम में ही खाएगा।
अच्छा ऐसा लिखा है क्या?
अरे वो एज्यूम कर रहे हैं। देख 3000 बनाना है
हम्म
और
हम्म
हाँ
टोटल मेरे को डिस्टेंस कवर करना है 1000 किलोमीटर। बट
हाँ
शर्त
हाँ
ये है कि 1 किमी जाएगा, एक केला खा लेगा, एक बनाना खाएगा कैमल।
हाँ, तो
हाँ
1000 किलोमीटर तो 1000 केले कैसे खत्म हो गए?
और एक साथ वो 1000 बनाना ही ले सकता है। तो अगर ऐसा सोचे कि 1000 ले जाता वो पूरा, तो भाई यहाँ पे 0 पहुंचेगा। फिर जब आएगा फिर दोबारा जाएगा, 0 पहुंचा, केला गया ही नहीं।
ऐसे नहीं होगा।
ऐसे नहीं
क्या
होता।
क्या?
आप
ये क्या
करके
है भाई?
लेके जा रहा हूँ।
मैं बोल रहा हूँ कि 1 किलोमीटर
हाँ
में एक केला खाता है कैमल, ठीक है।
हाँ
तो 1000
हाँ
की भी मेरे को कवर करना है, 1000 की भी कवर
हाँ
करना है। और मैक्सिमम 1000
हाँ
केला ही ले जा सकता है कैमल।
हाँ
तो
हाँ
कैमल यहाँ से 1000 की भी जाएगा, अगर ऐसे
हाँ।
जाएगा। तो 1000,
तो मतलब
1 किमी में एक केला खा लिया, 2 किमी में और एक केला खा लिया, ऐसे ऐसे करते करते लास्ट में मेरा 0 पहुंचेगा। यहाँ पे मतलब पहुंचा ही नहीं। तो कैमल दोबारा आया, दोबारा गया, तो ऐसे ऐसे नहीं होता। तो सॉल्यूशन थोड़ा डिफरेंट है इसका। मैं बता दूं कैसे होगा।
भाई वो खाना ही खाएगा।
हाँ
अरे नहीं यार।
अबे भाई वो बिना खाए कैसे जा रहा है? बिना खाए कैसे जा रहा है?
जाएगा भाई,
हाँ।
जाएगा भाई वो, उसको लेके जाना पड़ेगा वैसे।
देख मैं बोल रहा हूँ
नहीं
कैसे जाएगा।
मतलब क्या? बस
देख मैं कैसे सोच रहा हूँ इसको, कि मेरा कैमल है। तो मान ले मेरा डिस्टेंस अभी कितना है, 500। इसको आधा कर लिया।
हाँ। अरे पता है
सॉरी सॉरी, मान ले
भाई
एक
आधा
किमी अभी, 1 किमी गया।
हाँ,
तो 1 किमी में कितना मेरा लॉस हुआ, केला 3। तो यहाँ पे पहुंचा मेरा टू थाउजेंड
वो
नाइन
क्यों
हंड्रेड
होता
नाइन्टी सेवन
हाँ।
है? नहीं
अरे
नहीं
भाई
ऐसे नहीं जा
नहीं
सकते ना।
भाई,
वो तो
भाई वो
उधर
एक
ले जा
हजार
सकते हैं।
हाँ जारी ले जा सकता है। तुम कहाँ से
हाँ
अपना बना रहे हो? भाई वो
क्या।
जारी ले जा सकता है यार।
हाँ तो 3 बार
अबे
लेके गया ना। 1 किलोमीटर गया, 1 किलोमीटर आया।
हाँ तो 1 किलोमीटर गया, 1 किलोमीटर आया, वापस वहीं पे पहुंच गया जहाँ पे था।
देख देख देख, मैं
तीन
बोल रहा हूँ,
किलोमीटर
सुन
कैसे
सुन।
चल गया?
3 किलोमीटर नहीं है
ठीक है
ये,
समझ गया
तीन
उसके बाद।
किलोमीटर केला नहीं है ये। 3 किलोमीटर डिस्टेंस नहीं है ये, 1 किलोमीटर है।
हाँ वो 1 किलोमीटर 3 बार गया।
हाँ थ्री
मतलब एक
थाउजेंड
उधर रख
केला।
के है, ठीक है यार।
आयु समझे या नहीं समझे।
नहीं फिर से बताओ।
देख पहले 1 किलोमीटर गया, ये 1 किलोमीटर डिस्टेंस है। 1000
हाँ
मैक्स ले जा सकता है, तो यहाँ पे कितना पहुंचा, 99। देन वो मैंने कैमल को वापस लाया, वापस लेके गया 99, कैमल को वापस लाया, वापस लेके गया 99, 999, टोटल कितना हो गया 2997।
एक मिनट, एक मिनट, एक मिनट, एक सेकंड, फिर से बताओ मेरा, फिर से बताओ क्या सुनिए लगी।
अरे यार 1 किमी में डिस्टेंस ट्रैवल किया 3000
हाँ
केला है,
हाँ
तो कैमल 1000 केला इधर एक एक उसको खाने को दिया, 9999 इधर पहुंचा। सेकंड बार 1000 केला इधर से इधर ट्रांसपोर्ट किया, 9999 पहुंचा। थर्ड बार भी सेम 1 किलोमीटर डिस्टेंस ट्रैवल किया अभी तक।
अरे भाई, वो 3 बार एक बार में कैसे जा रहा है? 3 कैमल नहीं है ना भाई, एक ही कैमल है।
ये कैमल के तो वापस भी तो ला सकते हैं।
अरे तो वापस जाओगे तो 998 हो जाएगा ना। वापस लाने में केला नहीं खाएगा क्या?
वापस
नहीं नहीं,
नहीं खा रहा है उसको, वो एक अनदर कंडीशन है, उसको भी खिलाएंगे, वापस आने में भी केला खिलाएंगे उसको मस्त। ठीक है,
यार
वो भी एक कंडीशन है, वो वापस आने में भी उसको केला खिलाएंगे हम। अभी अभी के लिए वापस आने में कोई केला नहीं खा रहा है, उसके जब लोड बढ़ बहुत ज्यादा बढ़ रहा है तभी केला खा रहा है। 1000 केला जब उसकी पीठ में आ रहा है तभी वो केला खा रहा है। ठीक है, तो अभी क्या हुआ 2000 ऐसा टोटल केला हुआ, 1 किलोमीटर डिस्टेंस कवर किया। अब क्या किया कि ऐसे करते करते 1 किलोमीटर करते करते, तो अब क्या हुआ होगा 2994, तो टोटल 2 किलोमीटर ट्रांसफर किया।
तो खत्म हो जाएगा ना पूरा एक बार?
नहीं खत्म
हाँ
होगा, आप देखो, आप देखो
अगर
1000 केला खत्म होने में कितना टाइम लगेगा, ऐसे 3 खत्म हो रहा है, तो कितना डिस्टेंस ट्रेवल करेगा। 3 से डिवाइड किया तो 3000 पॉइंट समथिंग, बट ये नहीं लेंगे, एक कला 999, ठीक है, एक कला बच जाएगा। तो डिस्टेंस मेरा कितना कवर हो गया 330 किमी, और केला कितना बच गया 2001।
वन आगे 20,000 लिख दियो।
समझे कि नहीं समझे आयुष?
1,000, एक जीरो एक्स्ट्रा हो गया, एक जीरो एक्स्ट्रा हो गया।
अरे हाँ हाँ, समझे कि नहीं
समझ
समझे?
गए, समझ गए। हाँ
आप देख, आप क्या करेगा, अब एक जो एक है ना, इसको अभी छोड़ दे, इसको जीरो मान ले,
हाँ
क्योंकि देख तेरे को तू 1000 ले जाएगा, 1000 1000 एक बार में 1000 लेगा, दूसरी बार में 1000 लेगा, तीसरी बार में एक केला आने के लिए तू ऊँट को बुलाएगा, पर एक केला तो खाएगा, तो एक का कोई फायदा है नहीं।
हाँ
तो अभी तक डिस्टेंस मेरा कवर हो गया 333 किलोमीटर। अभी
हाँ
इसके बाद कितना केला मेरा खर्चा होगा, हर 1 किलोमीटर में दो, हर 1 किलोमीटर में मेरा दो केला खर्चा होगा, तो पहुंचेगा कितना 1998। ये 330 किलोमीटर के बाद 1 किलोमीटर डिस्टेंस करने में मेरा ये केला पहुंचा। ठीक है,
हाँ, ठीक है ठीक है ठीक है, समझ गया।
हाँ, तो अब मेरे को क्या है कि 1000 केला है, 1000 केला को मैं 2 से डिवाइड करूंगा, तो कितना है
हाँ
कि 500 किलोमीटर में
भाई
जा
भाई,
सकता हूँ।
हाँ
तो टोटल में डिस्टेंस कितना कवर कर लिया 500 प्लस 333, तो
हाँ
8333।
हाँ
अभी भी मेरे पास 1000 केला है,
और एक पहले से है।
आप क्या हुआ, इतना डिस्टेंस कवर कर लिया, अब जो डिस्टेंस बचा है वो तो एक एक देना ही
हाँ
पड़ेगा हर 1 किलोमीटर में।
हाँ
तो वो 167 केला और लेगा, मीन्स 833 आंसर। अल्टीमेटली तुम केला इतना मतलब एंड में पहुंचेगा।
नहीं, और एक ऐड होगा ना, 834 होगा।
अरे 4 कैसे हो जाएगा, यहाँ पे 2001 था।
पहले एक केला हम लोग तो, हाँ
2001 थ्री थ्री।
इसमें तो हम लोग ऐड नहीं किए ना।
अरे थोड़ा एक बार सुन ले।
हाँ
ये 33 किलोमीटर है।
हाँ
यहाँ पे तेरा केला कितना है, 2001।
हाँ
तो ये मान ले पूरा 1 किलोमीटर डिस्टेंस है। अबे यार ये दिखाई नहीं दे रहा, मैं लिखा पर अपडेट नहीं हुआ।
कुछ कुछ सुना नहीं हुआ।
हेलो, वेट कर थोड़ा वेट कर। हाँ, ये मान लेता हूँ मैं 1 किलोमीटर डिस्टेंस है इधर। तो कितने एक पार्ट में मैं भाग कर सकता हूँ इसको, 1000 क्योंकि मैक्स ले सकता है ये, और एक एक केला रह जाएगा। ये 1000 जो केला है, मैं यहाँ से लेके यहाँ तक डिस्टेंस कवर कर रहा हूँ, तो 999 केला पहुंचा। सिन्यासिस।
सॉरी सॉरी सॉरी, माय माइक प्रॉपर। ये
हाँ,
चीज समझ गया, अभी समझ गया।
और दूसरी
हाँ
बार ये 1000 है, ये पहुंचा इधर 99 हो गया।
हम्म,
अब ये एक केला रह
हाँ
गया, तू एक केला इसको लेने आएगा या छोड़ देगा, तभी एक केला ये खत्म ही हो जाएगा। क्योंकि अगर तूने एक केला लिया कि मैं भाई लेके ही आऊंगा,
वो तो खा ही लेगा।
तो वो तो खा ही लेगा, इधर जगह जीरो हो जाएगा। और एक केला
हाँ
तूने अगर
समझ गया,
छोड़ ही
अभी
दिया
समझ गया।
तो वो तू साथ में नहीं ला रहा है।
ठीक ठीक ठीक, समझ गया।
तो फाइनली आंसर 833, आई थिंक 8 कितना था, 833 आंसर।
ठीक, ठीक।
एंड ये कंडीशन है कि आने के टाइम कोई केला नहीं खा रहा है, दूसरा कंडीशन भी हो सकता है। ये देख आंसर कहाँ है भाई, 467।
फाइव
ये
थ्री थ्री
आने के टाइम खा रहा है 5। ये कैसे हो गया।
फाइव थ्री थ्री नाइन।
ये अलग आंसर है, नेक्स्ट का तुम फॉलो
अच्छा
कर।
ये देख, मैक्सिमम नंबर ऑफ बनानास दैट कैन बी ट्रांसफर्ड 833, वो है 533, जब वो आने जाने में दोनों दोनों बार केला खा रहा है। समझ गए ना।
हाँ 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 हाँ।
तो वही सेम कंडीशन लाएगा। ये 833 आंसर।
यार वो प्रैक्टिकली सोचो, अगर वो डायरेक्ट 1000 किलोमीटर चल रहा है,
हाँ,
ठीक है,
तब तो जीरो
ठीक है,
पहुंचेगा।
हाँ
उसके बाद सारे बनाना खत्म हो गए,
हाँ
फिर उसके बाद वो वापस आना
हाँ
है, मतलब जीरो बनाना आ रहे हैं, एक से दूसरे भी नहीं ट्रांसफर कर रहा है, एकदम से 833 आ रहे हैं। एक 1 किलोमीटर जा रहा है फिर वापस आ रहा है, 1 किलोमीटर जा रहा है
हाँ
फिर वापस आ रहा है, ऐसा।
हाँ, ये कॉन्सेप्ट है।
वो जो ये जो पजल बनाया है, वो लोग पागल है भाई। ये लोग कोई प्रैक्टिकल एग्जाम्पल नहीं सोचते।
यार ये क्वेश्चन बहुत, मतलब मुझे उसका खास समझ में आया नहीं, थोड़ा थोड़ा आया, मतलब
अरे मैं
चालीस
समझा
पचास
दूंगा,
सेकंड में।
ये इजी था। तू एक बार देख के सोचेगा, हो जाएगा ये।
कल वाला तो झट से समझ में आ गया था, ये इधर ये वाला तो नहीं आया था।
तो ठीक है, चल खाना खा के आता हूँ, थोड़ा मैं भी भूख
चलो,
लग गया।
हाँ